Hello! So, I got myself a new toy. I've actually got two of these. This is a KiwiSDR, and it is a 0 to 30 megahertz receiver. It has a nice little web interface, and you can just have 4 channels that you can just click through the spectrum and decode it as, or demodulate it as SSB. It runs off a BeagleBone. So I've got a BeagleBone black here. I think it works on the BeagleBone green, and it's just a shield that sits on top. You feed it an antenna. It's also got GPS. There's a little bit more to using one of these though, so let's go through what the plan is. This is going to be a bit of a vlog on setting up one of these at a remote receiver site due to the current circumstances. Not sure how quickly this vlog is going to come out. Wanted to go through all the components that I've got so far. We have our KiwiSDR. Now, at the remote site, I have an existing control box, and inside there has power and network, that sort of stuff. So that goes off to the cloud and it gives us power. Now, we want to get the KiwiSDR away from any sort of RF noise sources. So what I'm going to do is install a second box that's far away from this electrical cabinet, and it's going to have 2 cables going across from it, one for network and one for power. So what we'll have is a second control box, network, power in here, and the KiwiSDRs, because I have 2 of them, are going to hang out in this box here. Now, they're naturally going to have antennas, so one of these is probably going to be some sort of dipole, and the other one is hopefully a loop. There's actually a little bit more to this than just that, because we have a few constraints that we need to deal with. The loop is an active loop, so it needs power. So to get it power, there's actually another box that goes in here, which is a bias T, and that feeds power up the coax to the control box for the loop antenna. We also need 5-volt supply to the KiwiSDRs, 5-volt DC, and we need 12 volts for the loop antenna. Now, the hard thing about getting power to the KiwiSDR is you want it to be very clean, because we're dealing with fairly low frequency signals. Switch mode power supplies are sort of out because they will have some sort of spur or interference on somewhere within that 30 megahertz. So what we're going to do is we're going to use linear regulators. If we have 15 volts coming out of a transformer, so we have a transformer, we've got our coil that way, so we have 240 volts in this side, say 15 volts out the other side. That means that we need to still drop down to 5 volts somehow, and we can use linear regulators for that. But the problem with that is these KiwiSDRs, they will probably draw combined around 4 amps, maybe even more, and that's about 60 watts of heat essentially, because if we're drawing 4 amps at 5 volts on a linear regulator, we're going to be drawing 4 amps at 15 volts, which would be about 60 watts. So we're going to need to deal with cooling of that, and we won't be able to do just one stage of the linear regulator because there'll be too many watts in one regulator. So the idea is basically to run AC power between these 2 boxes, and then have a set of linear regulators inside this box here that will step our power down for our KiwiSDRs. So that's the idea. Now, let me show you some of the parts that I've got. the first thing I want to talk about is getting the power to that second box. And so this is what we have here. We have the transformer in the middle, and we can see the primary side. This one's quite flexible, gives us a few different options, and we'll be able to either tap the transformer essentially like up or down, depending on if we need to get the voltage higher or lower for the output. This is the output side. It's actually got two sets of 4 amp outputs. So if we need more than 4 amps, we'll be able to utilize this. Now, to make this setup a bit safer, we have 2 circuit breakers. So we've got a 6 amp one on the 240 volt side and a 4 amp one on the output. This 6 amp one is rated for 6 amps because it's actually going to have a few more things rather than just this transformer hanging off it. Then we have terminal blocks. This is all going to be mounted on DIN rail. So we've got DIN rail here. So DIN rail is really handy because a lot of electrical things use DIN rail. And if we get a screwdriver, so circuit breakers are mostly always DIN rail. Basically, you just have a little sort of spring-loaded clip here. You can slide it. Let me show you. Slide that on there, and then these ones clip in, but some things are spring-loaded. But yeah, so that's it in there. We've got the terminal blocks here. So let me show you how they work. All right. So this is one of the terminal blocks. Internally, this just has sort of a common bus, and you've got little holes here. So what you do, let me find some wire. So these are sort of 4-way terminal blocks. Now, the way these work is you put your wires in here, and these are just a way of connecting stuff up. Now, I'm going to show you this. It's a lot easier when it's in the rail, but I want to show you how these work internally. So with these ones, they're spring-based. So if we put our screwdriver in here, it requires a bit of force. You'll see it pushes that little spring open, and with that, see if I can stab myself. So we can put the wire through, pull out the screwdriver, then that's locked in place. And because of the way this sort of wedges up, it's very hard for the wire to come out. So this is just a way of connecting lots of things together. Just tying, say we need to tie a whole bunch of things to the transformer, then we can use these to quickly add them. Now these are really cool. So these usually sit on the DIN rail, and you can essentially stack these that way around, side by side, and you can have as many as you like. And then on the very last one, you have this this cover plate that just sits on there, and that stops you from being able to touch in here. And then finally, we have these clips, and these just hold them onto the DIN rail to stop them sliding side to side. Now the other cool thing is, so these two here aren't connected together, so you could have one positive, one negative, but say you need more connections, you'd use one of these little links, and those little links just snap in like that, and now these two are connected. So let's have a look on here, and let's install this one that we put wires on. So because it's DIN rail, all you need to do is just clip that in. But before I do that, I'm just going to put on this. That covers it up. And you can get them in all sorts of different shapes and sizes. I didn't do a very good job of clipping that down. There we go. I've put that one on opposite to that one, but that's all right. And then these here, same thing. They just clip on. They're sort of mirrored edge. So they take a little bit more force because they're designed to sort of lock these in. Actually, I'll show you, see how these can sort of slide side to side. Put those in place, can't slide anymore. So I've got a few things like the KiwiSDR that don't have DIN rail. So I'll probably end up 3D printing some DIN rail mounts. It's quite easy to 3D print DIN rail stuff. But I do have, you can get these generic DIN rail mounts that have just got sort of like 2 screw holes that don't quite fit for this use case. So I'll probably 3D print something, but they're quite handy if you want to mount generic stuff onto DIN rail. So this transformer and the circuit breakers is basically going in this box here, the first box. Because this is a transformer, it's going to provide AC output. We need to deal with turning that into DC and turning it into 5 volts. Right, this is where these come in. These are linear regulators. I'll put a link in the description for all these parts. These boards contain 2 linear regulators and 2 bridge rectifiers. So they're basically, you can think of this as essentially 2 boards mirrored, which is why there's 2 of everything essentially. So we feed AC into here and we'll get DC out, and specifically we'll get DC out at a set voltage. There's a little pot on here to change the output voltage. So we'll need to feed in AC, check the voltage on the output, and then adjust accordingly. Now these are going to get hot because, as I said, we've got 60 watts of heat to dissipate. And just think about like a 60 watt light bulb, how hot that gets. That gives you an idea of the heat that we're going to be generating off these. So we're going to use these in stages, and basically the very first stage is going to be about 13 volts. So we'll take our roughly about 15 volts AC, convert it down to 13 volts DC. Now the reason we want 13 volts DC is we need to feed this loop antenna. After we've fed that off the output of this, we actually feed these back into each other. Well, this is the plan, is to feed it back into the other side, and that way we can use both sides of the board. And we'll drop this down somewhere to like 10 volts so that we're only dropping 2 volts. And we'll do the same on this board as well. So we'll feed 10 volts from this board into this board. It's going to output say 8 volts. We'll take the 8 volts, feed it into the AC input on this side, and then we'll get hopefully 5 volts out here, which will be a nice stable linear supply for our KiwiSDR. Now there's still more. So this is a DC bias T, and so that would sit in this box here, and that's going to have DC power coming in from one of these. It's going to have RF coming in on this side. Well, more specifically, RF coming out. And on this side, this will have RF and DC. Output of this, the RF and DC, is going to be fed into the loop, and that will power the loop. And on this side, RF is going to come out and into our KiwiSDR. The other thing to think about is we're still going to have a whole bunch of noise, unfortunately. So I've got a whole bunch of these really big chunky ferrites that we should be able to wrap essentially all the cords that we deal with are going to have these ferrites around them, and that should hopefully reduce the noise. Finally, last thing is the box that I was talking about. Now this has a whole bunch of crap in it, but you can see this is just a metal box. It's got a metal backplane here, and this is what we're going to mount things on. We're going to put some DIN rail in so we can mount all the components, make it nice and neat. Down the bottom we'll put some holes in the bottom to get some cables in and out of. We've got shielded Cat 6 cables to make that all work. These are just more of those little DIN clips. So we'll need a switch to connect to the 2 KiwiSDRs. So that's the plan of how we're going to set this all up. I'm going to try and bring you along with me if I can. I've got the first things up is testing out that these boards work and the transformer works, and making sure that it's going to supply enough current for the KiwiSDRs. and then we'll see how we go from there. So subscribe to the channel if you haven't already and you want to see updates on this project. That's all for now.